When we collect a sample of data, we don't necessarily know what the mean of the population is that that sample was taken from, but we can calculate a confidence interval that represents the range in which we expect the mean value to fall. That confidence interval is based on the mean of the sample, and then we subtract based on the normal distribution the appropriate value from the standard normal distribution times the population standard deviation divided by the square root of the sample size. That provides our lower confidence limit, and our upper confidence limit is the same terms, but then we add z times the population standard deviation divided by the square root of n. This assumes that we know what our population standard deviation is, which in many cases is not available. Therefore, we want a way to calculate our confidence interval on the mean using S instead of sigma, which is our sample standard deviation. This is based on the data we've collected and not based on assuming that we know the population standard deviation. So the structure, if we use S, the structure of our confidence interval looks very similar. Standard deviation divided by the square root of n on both sides, but this is the sample standard deviation. The difference is that now that we're using S instead of sigma, sample standard deviation instead of population standard deviation, we now use the t distribution, which is similar to the normal, but accounts for the fact that we don't necessarily know our population standard deviation, and therefore it gives us a little bit wider spread in the data. We have the negative value down here. Just like the normal distribution, we have in our book a table that gives us probabilities of the t distribution. Again, we look at a certain probability and find the associated value of t instead of the associated value of z. Two main differences though. One difference is that when we look at the table, the values that it gives us refer to alpha being above a certain limit. Remember the normal distribution, that was a cumulative table, and as a cumulative table it gave us the probability up to a certain value of z. The t-table works the opposite way in that the values the table presents are for the area being above that limit. The second difference is that now our probabilities are located across the top. And instead of being inside the table, before with the normal distribution, our probabilities were down here. In this case, our probabilities are across the top, and the values for t are contained within the table. Now, if we want to find a value for the value of t that a certain percentage of the area falls above that limit, we need to know one more piece of information, and that is our degrees of freedom. Okay, degrees of freedom are located down to the left side here and are related to our sample size. The more samples we have, the larger the sample size, the larger the degrees of freedom, and it's calculated as the sample size minus 1. So if I take a sample with 12 samples, then my degrees of freedom are 11, and this is the row of values that I would look at to find t based on the area that I wanted to find here.